Hi everyone, it's Mrs. DeJong here. Today we're going to be doing lesson 4.2, which is all about integer exponents. There is a lesson 4.2 handout on Teams that you should fill in as you watch this video lesson. So if you look at your handout, there's a chart with 5 types of exponent rules, and we're going to fill in that chart now. So the first one is multiplication. And the example there is a to the power of 3 times a to the power of 5. So the first thing I'm going to do is I'm going to expand this out, which would be a times a times a, that's the a to the power of 3, all times a times a times a times a times a, 5 times. And that's the a to the power of 5. Now to simplify that, that would become a to the power of 1, 2, 3, 4, 5, 6, 7, 8. I have 8 a's multiplied together. So, if I had a to the power of 3 times a to the power of 5, and that became a to the power of 8, what was my exponent rule? It was when I multiply powers with the same base, I add their exponents. So the general rule here is a to the power of m times a to the power of n equals a to the power of m plus n. All right, the second exponent rule relates to division. The example here is a to the power of 6 divided by a to the power of 2. So I'm going to expand that out, which leaves me with 6 a's on the top and 2 a's on the bottom. Now, in order to simplify that, I would just start canceling out a's, and I can cancel out 2 a's here. So now I'm left with 4 a's, so a to the power of 4. So the exponent rule here is a to the power of m divided by a to the power of n equals a to the power of m minus n. So when you're dividing powers with the same base, you subtract their exponents. We have learned this before. This is just review, and we're going to be getting a little deeper into it. The third exponent rule is the 0 rule. So if I have a to the power of 2 divided by a to the power of 2, I would subtract these exponents because of the division rule. My bases are the same, so I can subtract their exponents, and that would leave me with a to the power of 0. If we expand this out, I would have a over a. I can cancel out all of those a's, which would leave me with 1, because anything divided by itself is 1. But it also equaled a to the power of 0. So, a to the power of 0 equals 1. The rule here is that anything to the power of 0 equals 1. The fourth rule is the power of a power rule. So I'm going to split this up into a, b, and c. So the first one is a squared, all to the power of 4. If we expand that out, we have a squared times a squared times a squared times a squared. Now, if I go back to the multiplication rule, if I'm multiplying numbers with the same base, I can add their exponents. So this would, simplified, would be a to the power of 2 plus 2 plus 2 plus 2, which is a to the power of 8. So the exponent rule here is a to the power of m, all to the power of n, equals a to the power of m times n. So here I did 2 times 4, would get me that 8 as well. The second example here is a squared times b, all to the power of 3. So if I expand that out, I have a squared times b times a squared times b times a squared times b. Simplify that. They're all multiplied together, so I can add the exponents from the a's and then add the exponents from the b's. So if I do the a's first, I have 2 and 2 and 2. So a to the power of 6 times b to the power of 1, 2, 3. So the exponent rule here is a to the power of m times b all to the power of n equals a to the power of mn times b to the power of n. So this exponent up here gets applied to the first term and to the second term. C is 2a over 2b squared, all cubed. So if I expand this out, I have 2a over 2b squared times 2a over 2b squared times 2a over 2b squared. I'm just going to multiply these. So 2 times 2 times 2 is 8. A times a times a is a cubed. Over 2 times 2 times 2 is 8 again. Times b squared times b squared times b squared. I can just add their exponents because of the multiplication rule. So that would be b to the power of 6. Now I can simplify this by canceling out the 8's, and I'm just left with a cubed over b6. The exponent rule here is a to the power of m over b to the power of m all to the power of n equals a to the power of mn over b to the power of mn. So both the numerator and the denominator get that n, the power of n applied to it. Right, the fifth exponent rule is the negative rule. And this is really related to the division rule. So if I have a squared over a cubed, since they have the same base, I can use the division rule and just subtract those exponents. So I'll be left with a to the power of 2 minus 3, which is a to the power of negative 1. Now, there's a way to write this without having a negative exponent, and that would just be 1 over a to the power of 1, which is just 1 over a. So if this here was a to the power of negative 3, then that would be simplified to be 1 over a cubed. So the 3 stays with the a, but the negative is gone because it's 1 over that number. All right, let's work through some examples here. So A, 5 cubed to the power of negative 2 over 5 to the power of negative 6. So in the numerator here, I have the power of a power. So I'm going to multiply the 3 and the negative 2, which leaves me with 5 to the power of negative 6 over 5 to the power of negative 6. Now I'm dividing with the same base, so I can subtract their exponents. Negative 6 minus negative 6 is the same as negative 6 plus 6, which is 0. So this equals 5 to the power of 0, which equals 1. B, 13 to the power of negative 5 times 13 squared over 13 to the power of 8, all to the power of negative 1. So I'm going to start by simplifying the bracket. So I'm going to get this negative 1 into the bracket. 13 to the power of negative 5 times 13 to the power of negative 2, because I did 2 times negative 1. And then in the denominator, I need to do 8 times negative 1. So it would be negative 8. Now I can simplify this here using the division rule, so I can subtract these exponents. So negative 2 minus negative 8, don't forget to do that double negative, is the same as negative 2 plus 8, which is 6. So this is 13 to the power of 6. Now I'm just multiplying two numbers with the same base, so I can add their exponents. So that will be 13 to the power of negative 5 plus 6 equals 13 to the power of 1, which just equals 13. All right, C. 3 to the power of negative 2 minus 6 to the power of negative 2 plus 3 over 2 times negative 9 to the power of negative 1. So in this situation, only that negative 9 is to that power of negative 1 because there aren't brackets around the 3 squared, or the 3 over 2 there. So I'm going to go through and start to simplify. The first thing I'm going to do is I'm going to get rid of those negative exponents, just because there aren't any numbers that have the same base, so I can't start combining exponents. So to simplify, I'm going to get rid of those negative exponents. So I would do 1 over 3 squared minus 1 over 6 squared plus 3 over 2. And then I have negative 9 to the power of negative 1. And that's the same as 1 over negative 9. The next thing I'm going to do is just simplify these denominators here. So I'm left with 1 over 9 minus 1 over 36. Plus, I'm going to do this division. 3 times 1 and 2 times negative 9 is 3 over negative 18. Now, in order to add and subtract fractions, I need a common denominator. In this case, it would be 36. So 4 and 1 and 6. So now I have 4 minus 1 is 3 over 36 minus 6 over 36. Oops, sorry. Which equals negative 3 over 36. And that can be simplified to negative 1 over 12. All right, D. D says negative 5 cubed and then times negative 25 to the power of negative 1 over negative 5 to the power of negative 2. So because I have some things that are the same base, this negative 5 and this negative 5, I'm going to simplify their exponents before I make them into fractions. I'm just going to get rid of those lines. So I would do negative 5 to the power of 3 minus negative 2. And then that's all still multiplied by negative 25 to the power of negative 1. So this will leave me with negative 5 to the power of 3 plus 2, which is 5, times negative 25 to the power of negative 1 is 1 over negative 25. Then I'm going to go through and solve what this is, negative 5 to the power of 5, which would be negative 3,125 times 1 over negative 25. This leaves me with negative 3,125 over negative 25, which is 125. All right, E. 5 to the power of negative 1 minus 2 to the power of negative 2 divided by 5 to the power of negative 1 plus 2 to the power of negative 2. So because these are added and subtracted and they're not being multiplied, I can't work across the division line here. I have to solve the numerator separately from the denominator. Okay, so that's the difference here, is that I can't do negative 1 minus negative 1 because these both have a base of 5. I can't do that because these are added and subtracted and not multiplied. So I'm going to work with the numerator first, and I'm just going to get rid of the negative exponents. So that would be 1 over 5 minus 1 over 2 squared. And the denominator is actually the same with an addition sign. 1 over 2 squared. I'm going to replace the 2 squared with a 4, because 2 squared is 4. Alright, I'm going to continue up here. So now in order to add and subtract fractions, I need a common denominator, which would be 20 in this case. So that would leave me with 4 over 20 minus 5 over 20 divided by 4 over 20 plus 5 over 20. 4 over 20 minus 5 over 20 is negative 1 over 20. And the denominator is 4 plus 5, which is 9 over 20. Now when I divide a fraction by a fraction, I can just multiply by the reciprocal. So I can do negative 1 over 20 times 20 over 9. Cancel out the 20s, and I'm left with 1/9. F. X to the power of 3 times 7 minus r. That's all the exponent. And then that's all times x to the power of r. So the first thing I'm going to do is simplify that exponent. So I'm just going to expand here. So 3 times 7 is 21 minus 3r times x to the power of r. Now both my powers have a base of x, so I can combine their exponents. They're being multiplied together, which means I can add the exponents. So I'm left with x to the power of 21 minus 3r plus r. And then I'll just simplify that again. Negative 3r plus r is negative 2r, so 21 minus 2r. And then G, 3x to the power of 4, all to the power of 6, minus m times 1 over x, all to the power of m. Okay, so I'm just going to start by simplifying these exponents here. So you have to remember that when you have a bracket, then this exponent applies to each term inside the bracket. So I'm going to have 3 to the power of 6 minus m, and then x to the power of 4 times 6 minus m, times 1 over x to the power of m. So 3 to the power of 6 minus m, I'm going to simplify this by expanding it out. X to the power of 24 minus 4m. And then I'm going to rewrite this so that it's not a fraction, which would leave me with x to the power of negative m. Now I can combine the exponents from both the x's because they're the same base. So I'm left with 3 to the power of 6 minus m times x to the power of 24 minus 4m minus m equals 3 to the power of 6 minus m times x to the power of 24, and then I have negative 4m minus another m is negative 5m. And that's it. That's the lesson. Let me know if you have any questions.